things together, concentrate, and to listen. We have a certain number of technical presentations after lunch, thus those are mainly engineering audience oriented. And before we start, I'd like to remind you a number of things. First of all, at ENOG.org, we have a place where we hide feedback form. It would be great if you will find that feedback form and you'll leave some things there, because it's important for us to understand whether you have any ideas you don't feel comfortable saying face to face, but you would like to put down. Thus, we are very much interested in your reaction, so we would kindly request you to find some time and leave that feedback. Secondly, possibly not all of you know that we have discussed at ENOG.org mailing list. There is a possibility to subscribe through the website. That is the place where we conduct discussions related to the event. There are some additional technical and near technical discussions we'll be bringing into the working group. Thus, yes, I invite you to subscribe for you to know what's going on. And let me remind you about the working group that we have launched, and the description of the first one is available on the website. And two more description of sessions of two more working groups that have been announced yesterday would be added. So we are inviting you to subscribe, and if you wish to join the existing ones, or if you wish to set up your own ones. And I believe that those who wanted to show up to come to this session are with us, and thus I'm passing on the microphone to Sergey. His presentation is a comparison of traffic balance equalization. Well, not to overload you, I would talk to you what the traffic balancing is. For those who don't know, what are the methods, what are the algorithms, we would consider the pros and cons of all of the available methods. Let's assume we have some service, web server of which lives on one single hardware. The service is working quite well, gaining popularity, getting more and more visitors. Thus, server load is growing with the increase of the burden of the traffic can grow to a certain point where when we are reaching capacity to the point where it grows rather than stops working at some point. We looked for the solution. The solution is called clusterization. You buy another server, you basically distribute your server on two servers, and we are living feeling happy that people will be going to different servers and the load will be balanced. And over time we see that one of the servers is working that way, still in the old way, and the other one is having few connections. Thus, that's called balancing. This whole process needs to be balanced. So what is that, and what does that procedure meant to resolve? First of all, we are distributing the load between the servers, as was mentioned.
So we had to provide this flow of requests so that both service works the same way. So when one of the servers breaks, the second server will accept the load if possible and processes the traffic. And thanks to the balancing, we can protect ourselves from some attacks. But there are some requirements to the balancing, and one of them is just the fairness. Every request should be served by one of our servers. So it should not be situation one of the because of the balancing, we should reduce the time for the query response, and for service of every user, and every algorithm of balancing should be predictable. And with the growth of the workload, it should bear this load. So the balancing should be scalable. So we should understand what algorithms should be used in different situations. Now, if we move on to the considering the methods of balancing, and one of them is the balancing of the channel level with the separate balancer. So on the special interface of every server, it can be a loopback interface. We put some IP address, and the queries for this IP address can come, and the server can respond from this address, but it shouldn't respond on the RP query. And our balancer will respond to the queries. So the balancer picks up what server will serve this query, and so it performs the distant and server processes. And so far as we didn't substitute this MAC address on the network level, so it beyond our balancer responds to the client. You can move on a little further and make it cheaper, so you can get rid of separate balancer, singled out balancer. So we should turn the incoming query into some kind of a multicast or broadcast. It can be done through using IP record, and we should use this such MAC address is the existing MAC or some kind of multicasting MAC, and when we then you will just multiply it, and every server should understand if it should request on this and so we divide it on the number of servers, and then we make decision whether the server answers this question or not. What's the plus of this algorithm? We don't depend on the protocols of the higher level. Using this balancing algorithm, we can balance STP, MTP, FTP traffic, and we make less time through, in the case of the separate service, which is big plus. And the plus is that the back traffic towards the user does not overload the balancer. It's important for the HTTP when the queries are quite easy, but the responses on the HTTP requires 10 or 100 or 1,000 times bigger. And one of the more pluses that we use only one public address, because IP addresses are quite limited. It's expensive resource, so using this balancing we save. And using this algorithm we can quite quickly add service in our cluster. The minuses of this system is that you need to put all servers in one segment, and there is some limitation on the incoming band, especially in the case of the separating addresses, because our query goes to all servers. And when we implement this, by the way, Linux Virtual Service implements this algorithm, the balancing on the network level, it's very similar to the previous algorithm, with only one difference, that we use not destination MAC, but destination IP. And the balancer uses what service should process it, so it changes the destination IP address and serves it for processing. It's being processed, and you have to perform the reverse operation, changing IP address, so that the client will be served properly. What's the advantages? As well as the previous method doesn't depend on a high-level protocol. For the service, we see the complete transparency. Servers think that they work with the clients and they don't know anything about balancer, and you use only one IP. The drawbacks is that it's increased load on balancer because of the back traffic, like in the case of the HTTP. So the Linux Virtual Server uses it, and this method of balancing is used very often in different hardware configurations. So balancing on the transport level And in this case, you have to take into account ports and sources and addresses. It's quite widespread method of balancing, and the balancing using the ECMP, equal cost multiple pass. So a lot of servers can balance traffic. You just can write the routes, but the routes should be different from the viewpoint of the router. And router started spreading the workload. You just have to keep in mind some nuances, such as all these packets in one session should go to the same server. Otherwise, there will be a TCP reset and the session will be interrupted. We also want to add and delete, remove servers, so that's where statics will not make us happy, and we can use some software implementations, BGP protocol like QuaggaLuBird, and in this case, servers will announce their own networks for router, and the router will spread the workload, divide the workload. If you want to control the accessibility of service on the applicable level, we have to use some script which will check the workability of our application, and there is refusal. So the advantage is that this algorithm of balancing doesn't depend on the high-level protocol. You can use only one public address, and there is no necessity to buy extra hardware. You need just router, that's it. And the drawbacks is that you need to install extra soft on server, and all connections are developed when you add or remove one sister from cluster, and there is such. Many routers have limited routes, and in our solutions we have several routers, and first two routers have about can support 2 routes, and the others about 32 routes. And means that timeout and BGP lead to the redistribution of the load. If this server breaks, there is some timeout during which router will distribute some or send some load on this broken server. Now let's look at some algorithms of global balancing. One of the simplest ones is the DNS balancing. It's quite simple. In DNS server, we add some records with the addresses of our service, and DNS server being addressed will send these addresses in a cycle order. So first server will get to first query, second, and so on. It will just go one by one. And the plus is that this algorithm completely independent on the high-level protocols and doesn't depend on the workload on server, because there are a lot of DNS servers. And it works in a way that it doesn't influence on the balancing of the load, and the clients from several DNS records pick up the random ones. This algorithm is universal. You can use it for the local balancing and for the global balancing if your servers are located in different geographical remote areas. And the plus is it's quite inexpensive and quick start. And any web resource has a DNS server. You just can add some records there, and you have some record of balancing. It's quite simple, but quite efficient. And the minus of it is that it's difficult to switch off servers. You need to wait till all cached in записи finishes, and it's difficult to distribute the load proportionally. DNS knows nothing about the traffic load on the server, and if it works at all. So you should monitor it somehow through script, maybe. The biggest minus of this algorithm that the more servers we have in cluster, the more public IP addresses we need to use. And it's necessary to use the double capacity just in case some server breaks, and we need to again keep one server in reserve. And the algorithm full proxy. Full proxy, we have balancer, which is some kind of a clever, smart proxy server, which as soon as it gets the query from the user, it can analyze the headline of the certain level, just process it, analyze cookies, and connect it some user to certain server. And during one session, all queries from this user will go to the same server. It can analyze the query to what resource user uses, and in different servers we can spread different content. If statics, you can go to one server, and some heavy content can go to other content. When analyzing the headlines of the applicable applied level, we can send it to certain servers. The pluses, the biggest pluses, are the server affinity. And as I said, when we have some adjustments of cookie, we can connect the users to the server. We spread different queries to different servers. We can analyze and modify queries from users. We can filter the queries and protect ourselves from some attacks, some kind of attacks. We can identify the workability of every node. We don't need to add any soft and controller. The balancer will do this work itself. The minuses is it's necessary to balance load on the balancers, so that on the applied level we have one more point of error which you can monitor. It takes a lot of resources when you analyze the resources used by the balancer go up, increase, and for each protocol you have to write every proxy server, which is quite inconvenient, and it's used in open source HA proxy and web server and Jinx. The redirect of the queries, it's quite limited uses. It's used on HTTP, and as soon as the user sends a query to our resource, the balancer answers with some kind of a mistake code, error code, and it tells you the address in which user can get the resource which is necessary. So the user will go and work with that address. The pluses are that we are distributing queries with analysis and compared with the proxy, and the minus is that it's limited usage with the protocols of the upper level and the increase of the time respond. So we have 2 queries to the server for every query from the client, and the web server in Jinx supports this algorithm of balancing. And the last method which I want to consider is broadly used the method of global balancing based on the anycast. It doesn't need from the user any additional adjustments or any additional equipment. It's very simple. From different geographically spread centers we announce the same prefix on BGP, and so the all queries to our server, the network will readdress to the closest one from the viewpoint of the connections between the web servers. It's very quick in terms of processing queries. Traffic goes not through the mainstream channel. The network itself distributes the load, and we don't need to monitor how the traffic load is spread. It's quite reliable, and if something happens with the server, so all of the inquiries will go to the queries will go to the next server. So if we conduct maintenance, for example, stop the server, so again it will be not a problem. The minus, it's if if you change the route, so the session will be stopped and not possible to control what node from the service the user was serviced, because we don't know where will be this specific user. So the equipment is quite expensive, and if you use BGP router, And they're quite expensive, and you have to keep in mind the interests of the internet providers. You know that all packages must go on the shortest route, but in reality it's not true. And sometimes operators redirect traffic in a cheaper way, not the shortest way. And the algorithm of the workload. I would like to tell you how the balancer makes decisions to what service the inquiry should be went. And the first algorithm is the weighted round robin, the DNS round robin algorithm. And DNS, we don't know how the server works, and we don't know about its productivity of the services. Using this algorithm, we can every server can assign certain weight according to its productivity and performance, and so send our queries to most productive service. And list connections algorithm, we take into account the number of active connections to this server, and we redirect the queries to this according to this information. Destination hash scheduling and source hash scheduling, these are algorithms of balancing according to the source IP and the destination IP. You choose something in statistical table, and this query goes to this other server. And the last one, it's a sticky sessions algorithm, which guarantees the connection of this user to a certain server. And all its queries will go to the specific server, and if the server breaks, so the queries will go to different server. And some words about the hardware solutions. I'll just give you some of them. So one of the solutions, Cisco ACE. It has performance about 16 gigabits per second and balances all methods which I've already mentioned. And next solution from Cisco is Cisco CSS. It has gigabytes gateways, gigabyte ports. And the big IP from F5 company, it's quite flexible solution. It has its own inbuilt script language, thanks to which we ourselves can balance traffic. And also this solution supports all already named methods of balancing. And the last, the AlternNG solution from the Redware company, is quite flexible solution, supports practically all algorithms and methods of balancing. It takes into account, can configure the cookies and connect and tie up the users to specific servers. So basically, that's it. That's yes. Okay, any questions? I can answer them. Probably lunch worked, had a soporific effect. Okay, colleagues, so probably you might have some questions, so someone would like to have some comments or maybe add up, say something that with these three companies. It's not the all companies which we were, not just these three companies.
Wonderful. Yes, I have a supplement about ECMP, about Affinity Server. You have not considered workarounds that would allow this affinity for ECMP. In our case, for example, on some of the hardware, we are having the so-called consistent hash technologies. With ECMP, we are calculating hash. We are taking the lower or younger bits, junior bits, and that gives us the index of next hop. In more modern equipment, for example, Juniper at whatever PC cards has consistent hash technology. And in that case, we are having not the next hop, but an index of some cell in redirection table. And if one of the servers gets out of the balancing, it should be a normal situation, we are simply rebalance the traffic of the server to others, and whilst the server comes up again, the traffic that was rebalanced through other live servers, we are redirecting back to the server that came back on the second workaround that we have implemented in Rumbler. We have, for example, 4 servers that are processing traffic, and the 5th one is serving as a backup of ours. Thus, in ERRP core we have, and the next hops are being represented by virtual addresses, the VIPs, and if one of the servers gets down, the number of the traffic of the server that is getting out is flowing to others. And my question is, how do you control sessions? How do you add stateless, everything stateless? I believe that state balancer is not so good, because state of balancer, we of course have state of balancers, for example PF, and they themselves have to be reserved and balanced preferably, because the thing is not so quick. That's what we need to do between the stateful balancers, is synchronizing the states, which is a relatively quite expensive situation, because in the synth flood is an additional point that would not serve. Thus, in this moment, we are going to stateless to the maximum. Do I understand correctly that you're talking about packet filtering? What does PF stands for? Free, yeah, it's packet filtering, 3 PSD. Okay, we are disclosing whatever this ciphered language. Okay, dear colleagues. At least 2 more people of those who want to ask or comment. And then could you please come? Evgenius Skov, Curator Labs. Mine is not a question, but a comment about BGP and ECAST, because it was mentioned that it provides for the minimal delays, and due to the fact that we were talking about the minimal distance in the term of the network infrastructure. In the network infrastructure, minimal distance doesn't necessarily mean from the geographic point of view. I would agree. And respectively, it's quite possible that we have some points or nodes, and we have an acceptable delay. We're adding an extra point with unicast, and the delays are growing. Yes, in this case, it's very good to have some base to connect respective addresses to post locations. Yes, thank you. Dmitry Krekov and Genix. I wanted to make a number of comments, supplement, because the colleague spoke quite well about the balancing at LT level. It was stated that Linux, whatever server, can do that quite fine. Yes, right. If we are talking about using it and as a balancer, talking about the scheme with RP, fixed ARPs at the on the switches of an NLB, talking about DNS balancing, we're talking about the need of double reservation. Is it possible to avoid double balancing if we give up some of the addresses? It's possible to make sure that the addresses are going into your neighbors have not just single address, but a number of addresses on the server. In case of 3 servers, just 2 addresses per server is best. And the third aspect about quite a noticeable drawback of the solutions with BGPs. With BGP, we can announce /24, which is what we have to give up. sacrifice. Yes, and we also have questions from the chat, and that as follows: what methods of balancing is being used by CDNvideo? Well, actually, we have our own methods. Something secret we didn't talk about. Yes, we can say that. We have quite a complex algorithm. We are calculating a matrix of about accessibility of every location, every network from where the user's request came. We are calculating the minimum distance to this user, be geographical as well as the network distance, the load on every server that will be servicing the users, and we are calculating complex metrics based on which we are deciding, and the solution decision is based on what? Is that session link, or is it criteria that laid over? It's being calculated in real time with metrics. As some tables that are being renewed. I cannot say that. You're not supporting the state. I don't think so, but I will have to clarify with my colleagues, those dealing exactly with that segment. Well, let me add myself. That was sub and A and P. There are people who love, who enjoy serious challenges in life, advantages, and wish to work as firemen, but came into network. I would recommend to implement A and P, because that's really exciting. Then I guess that's it. We thank very much the presenter.